So, welcome to the first day of Chapter 3. As a bit of a reminder, this is always the online day that we're on. But if you're following along in the book, these are the book chapters. Okay, so just keep that in your mind. Now, Chapter 3, especially this video, there's a lot of stuff we got to go over really quickly. So these notes are going to have a lot of stuff. The nice thing is this video in particular might be some review, might be mostly review. But today we are going to go over graphing, linear equations, solving, rate of change, and slope. Now because this video has so much information, I'm actually breaking it up into 2 videos. So part 1, this current video, is just graphing linear equations. Okay, this is part 1 right here. Part 2 is going to be the rest of this, all the way through solving, rate of change, and slope. So there will be another video labeled part 2 that will go over all of that. That being said, let's go ahead and get started. Okay, so a lot of this vocab will already be familiar with you when we went over graphing in chapter 1. If you need to go back and review those notes, that would be an awesome idea. But these are the basics that we'll be using again. So as a reminder, a linear equation is an equation that graphs a line. Now there are actually 3 forms of linear equations, so 3 different ways you can write linear equations. The one we're going to go over in this video, both part 1 and part 2, is standard form. Okay, now as you get higher up into math, standard form becomes a very big deal. You use it a lot. All right, now a couple things to know about standard form. These terms right here, ax, by, these are called variable terms. Why, you ask? Because they have variables right next to them. A is a number. B is a number. A, B, and C are all numbers. Okay, that's an important thing you got to remember. But A, X, B, Y, these are variable terms because the number is paired up with a variable. Now C is called the constant. Now it's called the constant because there is no variable attached to it, therefore it's always going to be whatever it is. Okay? Variable terms can change depending on what gets put in the variable. So depending on what x equals, this first term can change. But C, since there is no variable, will always remain the same. Okay? Variable terms down here as well. Other things to notice about this equation. Let me write this in red so you remember. A is greater than or equal to 0, and A and B cannot both be 0. Oops, that's not how you spell 0. There it is. What this means is, and we'll go in order. Number 1, what this means is that A can be 0, it can be 100, it can be 1, it can be 7/3. Whatever it is, it cannot be a negative number. Okay? Your first term always has to be positive. And that just goes into how we write standard and how we will use it later on. Now B and C, they can be whatever they want. B can be negative, C can be negative, all they want. A is the only number that cannot be negative. Now number 2, this says A and B cannot both be 0. Honestly, you could put in here as well at the same time. Okay, because as the first step says, A is allowed to be 0. But if A is 0, B can't be 0. And if B is 0, A can't be 0. So they can both be 0, they just can't both be 0 at the same time in the equation. Okay, because think about it. If you had 0x plus 0y, that's a really bad 0. 0y is equal to c, well, then you'd have 0 is equal to c, and that doesn't really make any sense. So whatever you do, both a and b cannot be 0 at the same time. Now, this is the general setup for standard form. Before we move on, draw your attention to this last line down here. If an equation has more than one x, it is not linear. Look at standard. ax by equals c. There is only one x. If ever you have x squared or two x's in your equation, the equation is not linear. So a, when you look at the a equation, there is only one x back here, so this is a linear equation. We can write this equation in standard form. Now, the way we do that is by getting it set up exactly as you see up here in standard. So that means ax has to go up front. So I'm going to add 3 to both sides, or 3x both sides. And now I have 3x plus y is equal to 4. Now this equation is written in standard form and it is linear. However, the second one over here, if you look over here at b, you notice that x is there and x is there. There are two x's in this equation, therefore it is not linear. And you can't do anything with it at this point in time. Later we may, but right now we're stuck. All right, some other things, and this should be a review from, we went over this in chapter 1. A linear equation can be represented on a coordinate graph. And all I mean about that one is your xy axis. So coordinate graphs, know that vocab word. We will come back to it, just that we'll use it all the time. So make sure you know what it is. Now, the x-coordinate of the point where the graph of the equation crosses the x-axis is called the x-intercept. So wherever the graph crosses the x-axis, that's the x-intercept. Same thing with the y's. Okay, the y-coordinate of the point which the graph crosses an equation, or the graph of the equation crosses the y-axis, is the y-intercept. So, important things to notice or remember is it's the x-coordinate is the x-intercept, and then the y-coordinate is the y-intercept. So down here in this picture off to the side, come on, correct color. Over here in this picture, my y-intercept is 2. And my x-intercept is -4. Now my y-intercept is located at the point 0, 2, and my x-intercept is located at the point 4, 0. But the intercept itself is just that coordinate. Okay. And in case you forgot, this is my x, this is my y. You should remember that from chapter 1. Now, for the most part, most lines will have two intercepts. They'll have an x and a y intercept. The standout exceptions are when we have y equals random number 3 and x equals, I don't know, let's go 5. 5 is a good number. Remember from chapter 1, these are still lines. Y equals 3 is graphed horizontally, like that. And then x equals 5 is graphed vertically like this. Notice that these graphs only have the one intercept, which makes sense because they're either horizontal or they're vertical. They're not going to have more than one. But for the most part, most lines have 2, except for these equations. These equations only have 1. When we're dealing with linear equations, we have this kind of triangle aspect of, I showed you on the board in class, you have the equation, you have the graph, and the table. I'll draw it over here. So equation, graph, and table. You need to be able to go back and forth from all of these. So equation to graph, graph to equation, back and forth between all of these. When it comes to tables, it is important to be able to find the intercepts and then be able to understand what they mean in real life. Because a lot of times when you get tables, when you get graphs in the real world, they relate to actual information. And so you need to be able to translate that information. So in this example, we have a swimming pool and it's being drained at a rate of 720 gallons per hour. The table shows the function relating to the volume of water and the time it's been draining. Okay. Find the x and the y intercepts of each graph. A good trick for whenever you're trying to find intercepts, because sometimes we can get confused, is to remember that x-intercepts are when y is 0. So we are looking for number 0. Actually, I'm going to turn that hashtag into an A and erase. Okay. Number and 0. And our y-intercept is when x is equal to 0. So 0, and I'm going to go with B since A is already in use. So for our x-intercepts, we want where y is 0. So as I look at my table, the only thing that fits the bill is down here. So my x-intercept is 14. My y-intercept is up here. So my y-intercept is 10,080. So now we found the intercepts, we have to explain what they mean in real life. My x-intercept, actually we'll go with y-intercept. We'll go from the top of the table to the bottom. So my y-intercept is when we have 0 hours and 100 or 10,080 gallons. At 0 hours, we have 10,080 gallons. So at the start of this whole draining process, we had 10,080 gallons. Okay. My x-intercept down at the bottom, 14 hours, no gallons, means that it took 14 hours for the whole pool to drain. And that's what it means to describe. When you're describing, you're using words and you're explaining what these random numbers mean in the real world. Because given the table, given a situation, they're not random. They actually have a meaning. And it's important that we understand what that meaning is. Now, I wrote these sentences almost as if they were bullet points. You can put them in a more proper sentence. Just as long as you have the correct information, will be fine by me. So now in our video, we've talked about the equation, we've talked about tables. Move on to the third piece of graphing. When you're graphing linear equations, right now we're going to be graphing equations written in standard form, as you can see right here. Oops, and pen. Now I'm going to rewrite standard form over here off to the side so you don't forget it. AX plus BY is equal to C. Now, when you're graphing in standard form, you are actually going to be graphing by the x and the y intercepts and then connecting the dots. That's why we just went over x and y intercepts. The reason why you're using x and y intercepts is because they're actually pretty easy to find in standard form. Let's start. When you want to find the x-intercept, all you do is plug 0 in for y and then solve for x. So to take this top equation, I have 2x plus 4. I'm going to plug 0 in for y is equal to 16. Well, this means that I have 2x is equal to 16. My x-intercept is 8. I'm actually going to go ahead and graph that over here. X is equal to 8. Now, to find the y-intercept, I plug 0 in for x. So I have 2 times 0 plus 4y is equal to 16. Solve for y is equal to 16. My y-intercept is 4. And there's my y-intercept. Now that I have my two intercepts, all I need to do is connect the dots, draw my arrows because this is a line, and now I have graphed it. And this is why we're starting off with the standard equation first. It's really easy to find our x and y intercepts, put them on the graph, and graph the line like that. Now there are a few special cases. Going back to what we said earlier, if you have a y equals or an x equals equation, then you're only going to have one intercept. These are just equations that you're going to have to memorize. You have to remember that x equals is a vertical line and y equals is a horizontal line. There's not much I can do to help you out with that one. I recommend flashcards. A couple of last minute facts, or not last minute, but towards the end of the video facts. Every ordered pair that makes an equation true is a point on the graph. Now what that sentence means, when you draw your graph, okay, let's just say here's my line. I'm just picking a random something. Every point on this line, if I were to plug it into my equation, it would give me a 4, I'm drawing a 5. A 5 equals a 5, or a 0 equals a 0. All right, it would make the situation true on both sides. However, if I were to plug in a random point from over here that is not on the line, okay, it wouldn't make sense. You plug it into the equation and you would get some random nonsense. And that's all this slide is saying. Any point on the line makes the equation true. And the line is a visual representation of all possible solutions that work for this equation. Now that we've gone over that, let's graph. So, in our triangle, we have equations, we have graph, and we have table. In the previous slide, we just went over going straight from the equation to the graph. Now we're going to go from the equation to the table to the graph and complete the triangle like that. Now, making a table is probably something you learned in middle school. Good for you. We're going to go over this, and it'll just be a review. So, a table, basic qualities of a table. You have your x, you have your equation, you have your y, and then I'm going to add this fourth category of what point am I supposed to be graphing. Now, for the x values, we can literally pick whatever we want. Okay, literally you can pick whatever you want because the domain for linear functions is always all real numbers. The domain for linear function is always all real numbers. So you can pick whatever value of x you want to plug into the equation. In my opinion, there are certain smart numbers that you can plug in, and you just recognize these easy numbers with experience. But right now, since we have a fraction, I know that since the denominator is a 3, I'm going to plug in whole numbers that will divide nicely with 3. So I'm going to start off with a -3 just to get things going. So 1/3 times a -3 plus 2. 1/3 with negative 3 divided by 3 is a negative 1 plus 2. This gives me a 1, which means my point is going to be negative 3, 1. All right, I'm going to speed through the math here just because the video is getting kind of long. If you have a question about how I'm doing this, please ask in class. Now notice my point, I cannot write the number 3. Notice my points over here are whatever number is in the x and whatever came out of the equation. So all I'm doing is plugging a value in for the equation, and then my answer is the y value. These little things, recognizing these little patterns, help you out later. All right, so now that I have all my points, I'm going to go ahead and graph them. Remember, x is first, then y's. So negative 3, 1 is right here. 0, 2 is right there. 3, 3. And then 6, 4. Now you really only need 2 points in order to graph a line. But it's always nice sometimes to graph more than one so you can get a clear picture. All right, this is the end of part 1. Stay tuned for part 2.